Hey guys, let's go ahead and read this first lesson of our brand new chapter, chapter 7, about the solar system. So before we read and fill out our outline notes, let's go ahead and get everything set up. So you can see here that our first section is what is the solar system. It's a pretty short one. Highlight that in purple, and then highlight objects in the solar system in green. And then if we scroll down a little further, we'll have one more section today. It's called the motion of the planets. Highlight that in orange. And then you can put your line right there. That's as far as we're going. And you can also see that there are your 5 vocab words. So if you don't have those finished, you need to get those finished very soon, okay? All right, so let's also go ahead and get our outline notes set up as well. So highlight what is the solar system in purple, objects in the solar system in green, and then scroll down to the motions of the planet in orange. And if you want to continue a little further, you can put your line because that's the end of lesson 1. Okay, come to lesson 2 next time. All right, so let's get ourselves set up so that we're ready to roll, okay? All right. So what is the solar system? The sun and a group of objects that move around it make up the solar system. So it's really going to be the sun and the planets. The planets are the ones that are moving around the sun. Okay, a few of the tiny specks of light that you can see in the night sky are planets in the solar system. But most are stars. It's hard to tell. Stars are not part of the solar system. They are much farther away than any object in our solar system. So remember, our solar system has one star, our sun. The stars that you see in the sky are part of the Milky Way galaxy, but they're not part of our solar system, okay? All right, so now we are ready to fill in our outline notes. So the planets in the solar system orbit the sun. The sun and the objects that orbit it make up the solar system. Okay. All right, that was a really short little section. So we are ready to go on to the objects in the solar system. Let's change our color here. Okay, the invention of the telescope in the 1600s led to the discovery of several planets and many other space objects. Before then, observers had only seen 5 planets: Mercury, Venus, Mars, Jupiter, and Saturn. The sun. The sun is a star and the largest object in the solar system. Its diameter is about 1.5 million kilometers. The sun is made mostly of hydrogen gas, and the mass makes up 99% of the mass of the entire solar system. That's crazy to think that everything else, all the planets, all the empty space, all of the asteroids and comets, that just makes up 1%. That 99% of our solar system is the sun. So inside the sun, a process called nuclear fusion produces a huge amount of energy. The sun emits some of this energy as light. The light shines on all of the planets every day. The sun's gravitational force causes the planets and other objects in the solar system to move around or orbit the sun. So that we have talked about in our previous chapters. Objects that orbit the sun. Planets, dwarf planets, asteroids, comet orbit the sun. These objects do not emit light. They reflect the sun's light. The figure below shows the 8 planets in the solar system. An object is a planet only if it orbits the sun and has a nearly circular, spherical shape. The object must also have a mass that is much larger than the total mass of all other objects in orbit nearby. All right, so we're going to change our color, and we are going to highlight all of that, because that's going to be very important for us when we distinguish what is a planet, what isn't a planet. Okay, so an object is a planet only if it orbits the sun. All right, number one, and has a nearly spherical shape. Number two, the object must also have a mass that is much larger than the total mass of all other object that orbits nearby. All right, so this is key. You will see this show up on your study guide, okay? So we have two groups of planets. We have our inner planets, and we have our outer planets. Our outer planets are also known as the gas giants because of the makeup of them. Okay, gas giants, and these are the rocky planets. Okay, so we have Mercury, Venus, Earth, and Mars as our inner planets, and then Jupiter, Saturn, Uranus, and Neptune as our outer planets. The inner planets and the outer planets. The inner planets are the four planets closest to the sun: Mercury, Venus, Earth, and Mars. My very excellent mother. The inner planets are made of a solid rocky material. You can land on them. The outer planets are the four planets farther from the sun: Jupiter, Saturn, Uranus, Neptune. Just served us nachos. The outer planets are made of ice and gas. And like I said before, these are our gas giants. Dwarf planets. A dwarf planet is a spherical object that orbits the sun and is not a moon of another planet. So let's go ahead and highlight that. A dwarf planet is a spherical object that orbits the sun and is not a moon of another planet. Unlike a planet, a dwarf planet does not have more mass than all of the objects in nearby orbits. The figure on the next page shows the dwarf planet series: Eris, Pluto, Maki. Dwarf planets are made of rock and ice and are much smaller than Earth. All right, so then we have asteroids, and I see a vocab word. So millions of rocky objects called asteroids orbit the sun in the asteroid belt between the orbits of Mars and Jupiter. All right, so that's going to be at this spot right here. Okay, so after here and before here. Okay, all right. Unlike planets, asteroids usually are not spherical. So a comet is made of gas, dust, and ice and moves around the sun in an oval-shaped orbit. Comets come from the outer part of the solar system. So we're going to learn about that, and when we look at lesson 4, that's out there in our Kuiper Belt Oort cloud area. Possibly 1 trillion comets orbit the sun. That's pretty cool, isn't it? Okay. All right. Our last thing before we get to our last section, the astronomical unit. Astronomers need a unit larger than the kilometer to measure the great distances between objects in the solar system. They use the astronomical unit. An astronomical unit is the average distance from Earth to the sun, about 150 million kilometers. For example, the average distance of Mercury from the sun is 0.39 AU, or about 54 million kilometers. All right, it would just get way too large of numbers. So they decided, all right, so from the sun to Earth, let's call that 1. Okay, that's going to be 1 AU. Anything prior to, so your planets that are prior to, are going to have a AU less than 1, like Mercury, okay? It's prior to the Earth. And so you're going to have other AUs that are much larger because they are much farther away. And we'll talk about that when we get into that section in our book, okay? Alrighty, so let's get into our notebook. Outline notes this time, sorry. Okay, so the largest object in the solar system is the sun. Okay, it makes up 99% of the mass. The sun is a star made up mostly of hydrogen gas. We know it's hydrogen and helium, but mostly hydrogen. Blank produces enormous amount of energy in the sun. We know that that is nuclear fusion. Objects orbit the sun because it applies gravitational force on them. Objects that orbit the sun include planets, dwarf planets, asteroids, and comets. These objects reflect the sun's light. You know, the only object that makes its own light is going to be the sun. Everything else reflects that light. A planet has a nearly spherical shape. Almost. The mass of a planet is much larger than the mass of nearby objects. There are 8 planets in the solar system. The 4 planets closest to the sun are called the inner planets. The inner planets are made mainly from solid rocky material. The 4 planets farthest from the sun are called the outer planets. Outer planets are made mostly of ice and gas. Because the outer planets are much larger than the inner planets, they are sometimes called gas giants. A dwarf planet is a spherical object that orbits the sun, is not the moon of another object, and has less mass than any of the 8 planets. Millions of small rocky objects called asteroids orbit the sun in a belt between Mars and Jupiter. A comet orbits the sun in an oval-shaped orbit and is made of dust, gas, and ice. The astronomical unit is used to measure long distances in the solar system. So astronomical. And that's capital A, capital U. 1 astronomical unit is the average distance from Earth to the sun. And that is approximately 150 million kilometers. Okay. All right, we see that we are at our next section. The thing is, with this particular lesson, this is really just a preview of the topics that we're going to be covering in this particular chapter. So lesson 2 is going to be all about the inner planets. And so lesson 3 is going to be all about the outer planets. And lesson 4 is going to be all about the dwarf planets and other objects. So that's why in this section here, they didn't go into a lot of detail, because we're going to go in more detail when we cover that in the individual chapters, okay? All right, so I see that I am at my next section. So I'm ready to roll, okay? The sun's gravitational force pulls each planet toward the sun. This force keeps each planet moving along a curved path around the sun. So we know that the two forces that keep objects in orbit will be gravity and inertia. Okay, so here are going to be, this next section is going to be very familiar to you because we studied Earth's motion of revolution and rotation, and we're going to learn that all the planets have revolution and rotation. So objects in the solar system move in two ways. Let's go ahead and change this. The objects in the solar system move in two ways. The objects orbit or revolve around the sun. So I see a vocab word here, so I'm going to switch it out. The time it takes an object to travel once around the sun is its period of revolution. Earth's period of revolution is 1 year. We know that. Okay. All right, so then we also have our second motion. So we know that revolution and rotation are the two motions. Okay, so the objects also spin or rotate as they orbit the sun. The time, oops, did not get that switched out. The time it takes for an object to complete one rotation is its period of rotation. Earth has a period of rotation of 1 day or 24 hours, right? So we're going to, as we look at the inner planets and the outer planets, we're going to look at what is its period of revolution. How long is its year? What is its period of rotation? What is its day? All right, so we'll take a look at that. We know Earth's 365 and a quarter and then 24 hours, but what's going on with the other planets? We'll find out, okay? Planetary orbits and speeds. Let's change the final color. A planet's orbit is an ellipse, an stretched out circle. And there was a scientist a long time ago. His name was Kepler. He was the one who discovered that. The two special points, each called a focus, are inside that ellipse. The focus points, or foci, control the shape of the ellipse. The sun is at one focus, and the other focus is empty space. A planet's distance from the sun changes as the planet moves along its elliptical orbit. Let's highlight that. A planet's speed also changes as it orbits. The closer the planet is to the sun, the faster it moves. This also means that planets farther from the sun have longer periods of revolution. For example, Jupiter takes 12 times longer than Earth to revolve once around the sun. Okay? All right, there we are at our line. There we are at our vocab words. Okay. Let's go ahead and fill in our last little section, our outline notes here. One way an object in the solar system moves is by orbiting or revolving around another object. The amount of time it takes an object to revolve once around the sun is its period of revolution. Objects in the solar system also spin or rotate. The time it takes an object to rotate once is its period of rotation. This makes sense, doesn't it, guys? We've studied this already. The shape of a planet's orbit is an ellipse, which is a stretched out circle. The sun is at one of the foci of the ellipse, so the distance between a planet and the sun changes as the planet moves. A planet moves faster when it is closer to the sun than when it is farther away. All right, we come to the end of our lesson, so make sure that you have everything filled in. Make sure that you have your vocab words done for this lesson 1, okay? All right, have a great day, guys. Bye.